Good evening, dear students. Today we are going to learn about the important topic of the chapter 3, atoms and molecule. The important topic is how to write the molecular formula of a compound and how to calculate molecular mass of a given molecule. So we have learned earlier atoms combines to form molecule. Now this molecule may be for the elements or maybe of the compound. Then how this molecular formula is formed? Example, if we are considering the water molecule, then water is always written as H2O. Why not it is HO, or why not this is H3O, or why not it is water is our H3O2, means any arbitrary one. Why these are not, or these are incorrect, but H2O is correct? What is the reason behind it? So how to write the correct molecular formula, those things we are going to learn today. So a student, for that we need to understand few things, or we need to recall some of our concepts that we have learned earlier. Example, if I am writing say O2, what this represents? A student, this 2 which is in suffix, this 2, this represents our number of atoms of oxygen in one molecule. So this suffix which is written after the symbol, that gives the number of atoms in one molecule. It simply means that. So here if we are denoting as O2, so this O2 means it is representing one molecule of oxygen. Get it? But it may be asked, one molecule of oxygen contain how much atoms of oxygen? Then that is obtained by looking their suffix. Okay, at the end what is written? So this one molecule contain means it have how much atom? 2 atoms of oxygen. But if the symbol is written like this, say only O, what it represent? So only O represent, it is oxygen atom. Oxygen atom. How much atom? It is the denotation for oxygen. That is, it is only one atom of oxygen. A student, this only O can never be called as a molecule, because molecule exists in free or independent state. But O cannot exist in nature as a single atom. O always exists by combining 2 oxygen atoms together as molecule O2. Okay, student? The third one, if I am writing like this, say if it is written like this, 2O, what it represents? Can be called, is this a molecule? Third one? No. Good. A student, no. Third one, though it have 2 oxygen atom, so it represents 2 oxygen atoms. But these atoms are not in molecular form. Okay, now student, this makes difference. But not as molecule. So it simply represents 2 oxygen atom is there. Okay. Though if O2 is written, it represents two kind of information. One is one molecule, and that molecule contain how much atom. So why this oxygen exists as O2 or O3 only? Those things we will understand today. It is called what? Molecule formation. Students, if let me take the fourth example. If I am taking H2O, what it represents, student? It represents first how many type of atoms are there. So student, here what are the different type of atoms? So type of atoms, what are the different type of atoms here? One is
hydrogen and oxygen.
Very good. So one is hydrogen, in symbol form denoted as H, and second one is our oxygen, which is denoted as O. Okay, student. So it is the first information that we are getting from this. In addition, how much oxygen atom is there and how much water molecule is there? A student, here we have to keep in mind something, that for hydrogen the 2 is written, but for oxygen nothing is written. So wherever nothing is written means here what is the suffix? If nothing is written, it means
One.
oxygen is one atom. So that we need to understand, it is one atom. So considering the atom, we can write the number of molecule is how much, student, is this? How much water molecule? The number of molecule is decided by the number before it. What is the number before it? Nothing is written here. So here nothing is written before this entire molecule, means here this is also 1. So whatever written before the molecule, it gives the number of molecules. Number of molecules. Okay, like here we have seen in oxygen, for oxygen we have taken in example 3 as 2. The 2 was representing number of atoms because oxygen was written as O. So 2 atoms. If it is written as 2 of O2, then 2 oxygen molecule. Those things we will also understand. A student, so let us consider for this water. So number of molecules is observed by considering the multiplication factor before the entire molecule. But in the suffix, whatever written, that gives us the number of atoms. Therefore, here we can write this entire one is representing how many molecules of water? Yes, if anyone is asking to you, how many molecules of water? Yes, can you tell me, student? So whatever the number written here means before this H2O, nothing is written means it is 1. Okay?
1.
So therefore, number of molecule of water, whether you write the water or H2O simply, it is 1. But this water molecule itself contains various kind of atoms and the total atoms also. Considering the total atoms, we can say its atomicity. Okay, student? So total atoms in one molecule of water, what it will be?
3.
Very good. So this is obtained by counting the number of hydrogen atom. So it is, we are getting hydrogen is 2 and oxygen is 1. Means 2 is of the hydrogen atom, 1 is of the oxygen atom. So it is total 3 atoms. It is this one. So this gives its atomicity. So atomicity of water is how much? It is 3. This. If it is asked by separating this, number of hydrogen atoms in one molecule here, how much? It is this number 2. We had already written, it is 2. Number of oxygen atom?
1.
1.
Very good. So it is our 1. A student, can it be asked number of hydrogen molecule in one molecule of water?
1.
How?
1.
You are just saying it is like our H2, so you are considering this as molecule. A student, this is the difference you have to understand. So number of hydrogen molecule in one molecule of water. A student, if you are considering the molecule itself, then in one molecule of water, this H2 you cannot consider as the molecule of hydrogen present. 2 atoms are present and they are just written as H2. Getting? So writing this way or asking this way, this is a wrong concept. Okay, student? So you shall not get confused that number of hydrogen molecule is 1. No. That is wrong. Okay? So it is a wrong kind of thing. So number of hydrogen molecule in one molecule of water doesn't carry any sense. So such questions are never asked. But by the way, if anyone is saying like that, then it means it is our 0. So it do not contain the entire molecule of hydrogen, but 2 atoms of hydrogen are present here. Those 2 atoms of hydrogen are written as H2. Okay, student? So do not confuse that it is H2 is the hydrogen molecule. So H2 is not hydrogen molecule. Okay, so it is wrong concept. So do not get confused with this. So it is simply representing one molecule of water. A student, by the way, if the question is like this, say the 5th one, say for NH3, if it is written like this NH3 is called as ammonia. Means this is the formula of ammonia. Like water, this ammonia is also a compound. Yes, student, if this is written and it is asked for this symbol, I mean 4 before NH3 is written, what is the total number of molecule present here? Total number of molecules of ammonia written here. Okay, what is that? It is representing this 4. Okay,
4.
likewise it may be written like this. For water itself, 3H2O is written. What does it mean? It simply means 3 molecule of water. Okay, student, like this. So if the coefficient of the molecule is more than 1, then how these atoms change, those things we will discuss. A student, in this I have taken the example of ammonia, NH3. Before that the coefficient is 4. So considering this 4, we can say the number of molecule is here 4. Okay, another thing, What is total atom of nitrogen? What are the type of element? Can you tell? Type of
Hydrogen.
Nitrogen,
very good.
hydrogen.
Elements or atoms basically. It is one is nitrogen and another one is hydrogen. Okay. Then it may be asked how many atoms of nitrogen is present in this?
1.
4H2O. Yes,
One.
tell me how many means these 4 NH3 I have written. So here it is asked total number of nitrogen is equals to how much? Here it is given that the molecule is 4 in number, but if it is just one molecule, so only NH3 is written, then in this case we are observing the number of nitrogen atom is how much? Here it is 1. Number of hydrogen atom is how much? Here it is 3. Okay. But
3.
in our case, what is given? 4 times NH3 means this nitrogen will also multiply with 4 and hydrogen will also multiply with 4. Okay, student? So number of nitrogen is obtained by considering the coefficient 4 and number of nitrogen atoms in each molecule, means 4 into 1, it is 4. Are you getting this way? Because for nitrogen, in one molecule of ammonia there is one atom of nitrogen. So here we have taken 4 molecule of ammonia, so the number of nitrogen will also be 4. What is the total number of hydrogen atom?
12.
Very good.
12.
So here it is nitrogen atoms basically. So this
4
is
into
obtained
3.
by considering the multiplication factor 4, and whatever for hydrogen the suffix is there, it is 3, it is our 12. So now I hope you people are getting what is the difference between coefficient written before a number and what do we mean by suffix written after an element. Okay, student? So this, for understanding this, I had explained. Now, after this, how this NH3 is formed? There are various other molecules. Okay, like if we consider the 6th one as say HCl, it is called as hydrochloric acid. Students, here we have to keep in mind for hydrochloric acid, again, what this HCl represent? It is one molecule of HCl. It simply means, okay, one molecule of HCl, entire one. But it may be asked, how much hydrogen atoms are present here? Number of H atoms?
1.
Good. Nothing is written after H.
1.
It is 1. Okay. It may be asked number of carbon atom. Yes, student. Sorry, carbon atom is there. No, this C doesn't represent carbon.
Chlorine.
Yes. Good. So it is our chlorine atom. It is
1.
also our 1. Okay. So this Cl is acting together. So remembering the symbol of element is very important. Otherwise, many a time students are getting confused. Okay, this way. So therefore, we have learned in a molecule, what do we mean by the atoms present? And what do we mean by the total molecules? So by considering these 4 examples, O2, simply one molecule, but it contains 2 atoms. only O is written, it represents atoms. It never represents molecule, because for molecule formation, something in suffix or at least more than one atom is required, in which something must be written in suffix or different kind of atoms is there. So it is the only noble gas which are exist as monoatomic, means only their atoms, they are not combining to form the molecule. So their atoms and molecule mean the same thing. If it is written as 2O, it represents 2 oxygen atom, but it doesn't represent molecule. Okay, if I am considering H2O, for this H2O we have learned, so the H2O, it is only one molecule, nothing is written before this H2O, means multiplication factor is 1. The type of atoms can be determined by looking the formula that we have learned. The number of atoms of each kind or number of atoms of each element can also be determined by looking their suffix. This for oxygen, nothing, means it is 1. This thing, the total number of atoms by adding this thing that we have learned. Another, if the multiplication factor before a molecule itself is written, like here the multiplication factor for H2O was nothing, means it was 1. But if we consider the NH3 as ammonia, before that the factor 4 is written. So in this case, this 4 have importance that it is representing the increase in molecule. So when the molecule, number of molecule is increased, the number of atoms will also increase accordingly. So considering this, it represents the 4 ammonia molecule. Now coming to the type of atom, nitrogen and hydrogen. So this coefficient 4 doesn't mean any new type of atom, but the same type of atom have increased. Now total number of nitrogen for one molecule, if we are considering only one NH3, it means it contains one nitrogen. But since it is increased by 4 by writing the 4 before this NH3, so that one have to be multiplied by this 4. So number of nitrogen atoms in this 4 NH3 is 4. Number of hydrogen 3 will also increase by 4, become 12. If we are taking HCl where nothing is there, in such a case we have to keep in mind this Cl represents one symbol, chlorine. So we shall not confuse with carbon HC. So here number of atoms, molecule, those things we can also write. So this was all about. Now how they say why HCl is formed? Now the question is that why HCl is formed? Why not H2Cl is formed? Why not HCl2 is formed? Why these things are not formed? Why this is formed? For this we have to understand what is the molecular formula. How to write the molecular formula. A student, molecules are formed by combination of atoms or group of atoms. So let us go for that. How these atoms are combining. So right, student, molecule formation. Molecules are nothing but combination or linking of atoms. So molecule, it contain more than one atom, more than one atom. These atoms are linked together, but here we have to excluding which molecule which are exist as single atom, excluding noble gas. Okay, these noble gas, what they are? Helium, neon, argon. These three things at least you must have to keep in mind. Other one is Jane and radon. A student, these exist as single atom. They do not combine. So it is exist as single atom. So single atom molecule is called as monoatomic molecule. So H always exists, means He, helium always exists as He. So it represents one atom you may call, or you may call one molecule of helium. Because helium do not combine, but the better term is to use this atom itself rather than confusing with the molecule. Therefore, for definition of molecule, so molecule must contain more than one atom excluding the noble gas. Now this molecule, these atoms are linked. Atoms are linked or bonded. How these atoms are bonded? For that, these atoms first form either positive ion or negative ion according to their valency. Then opposite kind of ions get attracted. That is one way. Another way is some electrons are shared. What is this electron? We will learn in our next chapter. That inside the atom there are some fundamental particles called electrons. Okay, so atoms are linked. So these atoms are linked. So how they will link? So according to their combining capacity, means they have the tendency to combine in that way only. Okay, so combining capacity, that combining capacity is called as valency. Now this valency or this combining capacity is either by forming their ions or by sharing the electrons. These things means how they are sharing their electrons and how the electron transfer to form ions, we will learn in class 10th. But here you have to simply keep in mind certain number or certain magical number is associated with particular atom to form ion. Now even the group of atoms can also show some ions. So those two things we will understand. So student, please complete this. It is very important. Atoms are linked or bonded according to their combining capacity called valency by forming ions. Ions are what? They're charged particle. Means the same atom will get charged, get a magical number, either positive or negative. Positive and negative are attracting each other to hold to form a molecule by forming ions. So these atoms will first form ions. Okay, now this ion formation depend on its combining capacity. Combining capacity means the tendency to have the state of noble gas. For attaining the noble gas, how much it is deficit, means how much electron is required. So by that way it is taken as negative valency, and how much extra is there, that is called as their positive valence. So these two things, by forming ions or charged particles, by forming ions and opposite ions, or here one thing more is there, all right, and opposite ions are held together, are attracted, and total charge on molecule get neutralized. What is this statement? We will explain. I will explain with example. It is the key thing for forming the molecule. It is the key thing. Okay. So what is this key thing? That I will explain. Now there is another way of combining. So by forming ions, it is one thing, or there is or condition. We will learn more in class 10th, or by sharing electrons. What is this sharing of electrons? This we can understand only after knowing the structure of atoms. So that we will learn after the next chapter. So this topic is not in your book. This much means how the ions are formed and ions get attracted to form a neutral molecule. This we have to learn in this chapter. Student, these are the two methods. Now the important thing here we have to understand why the atoms shows this combining capacity and forming ion, and which kind of atom will form which kind of ion. So another notable point is here that also write a note. So certain group of atoms also shows net positive or negative charge. Okay, so there will be some group of atoms, means it appear like molecule, but they carries positive and negative charge. So they are also the ions. They are not the molecule. They are ions. Write in bracket, not molecule. A student, now we shall understand whatever the things we have written. Understand each and everything very carefully. The ultimate purpose is, so what is the idea behind this, or the tips that you have to keep in mind? You have to keep the serial number, or call the atomic number basically, of each element. This first you have to keep in mind. Then you have to keep in mind the noble gas. They do not have combining capacity. So first point is this. The second point, noble gas do not combine, means they have zero valency or zero charge. Okay. Third one, so what are these noble gas that we need to keep in mind? Is our helium, neon, argon, xenon. Okay, student. The third point is that element just before this noble gas have the tendency to gain electron or to become negative ion. So atoms before atoms or elements, okay students, or if you have doubt, then you may write in bracket or elements rather. Before, so how much elements we shall take? Up to 3 elements only. So there, if they are before noble gas have tendency to gain electrons. Electrons I will define later, but here it is important to understand. That's why I'm using the term electrons, and form negative ions called, these negative ions are called as anion. Okay, it is this one. How is this? Example, a student, let us take neon. We are knowing neon have the serial number or atomic number, how much? 10. Now you just go before this. Before neon, what is there? Fluorine. Before fluorine, there is oxygen. Before oxygen, there is nitrogen. And before nitrogen, what is before nitrogen? It is the carbon. A student, that table you have to keep in mind. So if you are moving just before one number before this noble gas, then the valency of this fluorine or the charge carried by this fluorine will be -1. Okay, because 10 minus 1 we are able to reach to fluorine. Now coming for the oxygen, how much back you have to go? 2 unit before this neon, so its valency will be your -2. Are you getting? So this thing you have to keep. So this is the magical number -1, -2, because the tendency of these atoms is to become noble gas configuration by gaining electron, so it becomes negative. How is this noble gas electronic configuration? How they are gaining? This thing we will learn more in our next chapter. But here we have to keep in mind whatever the charge it can carry. So fluorine can form what, or how the fluorine can exist? So this simply means the fluorine can exist as F minus. Okay, student. The oxygen can exist as, for combining to form the compound, oxygen is always taken as O2 minus. So this is occurring for the combination only, not existing in free state. Okay, student. Nitrogen is deficit of the 3 or 3 state before this, so -3. Carbon, now student, it becomes
4.
simply 4. Okay, if we further go before this, then up to 3 or 4 before a noble gas you have to look, and similarly 4 after this noble gas you have to look. So after this neon we have this sodium we can see, then there is magnesium, Mg we can see, then aluminium, then silicon, then sulfur, then chlorine. Write this. Silicon, then there is one more called phosphorus. You must keep in mind the table I had written. The sulfur, the chlorine, then there is argon. Okay, students, so understand. Argon is again noble gas. So if you are looking neon, after neon you have to look for the 3 only. So it is our sodium. So what will be the charge shown by the sodium? For sodium, it is 1 ahead. So it is become like 10 plus 1 to become 11. Because their number we are knowing. Sodium is at 11th serial number. So the serial number is first very important. Then magnesium means it will show +2. Then aluminium +3. But this up to 3, if it is after the noble gas, it is taken positive. If it is before, then it is taken negative. While reaching to 4, no need to take any positive or negative. Now going ahead, after this we are getting these three are just before the argon. So we shall start thinking from the argon as before, not after. Okay, this is the trick that you have to keep in mind. So for chlorine, it is just before the argon, which is noble gas. Therefore, it is 1 before the argon, so -1. Sulfur, 2 before, so -2. Phosphorus, 3 before, so -3. This way, we can understand how the fluorine will be used in reaction to form, or how the fluorine is combining to form molecule. Students, this fluorine will first form F minus. Okay. Similarly, if we have this chlorine will also form what? Cl minus. Okay, student. Similarly, we may take the other one, say oxygen. What the oxygen will form? O2 minus. So this was considering the negative one. If we are considering just after this noble gas, say sodium, which kind of ion it will form for forming the molecular formula? Na plus means 1 unit.
Na plus.
Okay. Good. If we have the magnesium Mg, what it will form? Mg 2 plus. Okay. Here I have written for the negative only. Similarly, for positive we will write. Say for aluminium, if I am taking, what it will form? Al3 plus. Are you getting a student? Now, any of this negative will get attracted with any of the positive. A student, you just observe. I am considering, say, the chlorine. So chlorine means chlorine will always exist as, or for formation of molecule, chlorine will act as Cl minus. Now considering the other positive ion or the other element near to this chlorine is our Mg. So Mg have 2 plus, means 2 unit positive charge. Now if chlorine is combining with magnesium, then what will be the formula? So for that, here we are getting the charge have to be neutral. A student, from chlorine the charge we are getting is -1, but from magnesium the charge we are getting is +2. So a student, when these two charge means when this 2 can leads to 0, means how this can produce you 0, and you are free to multiply any of this. This is possible only if you are multiplying this number by 2 and adding this 2. Are we getting? So it becomes 0. So this factor 2, which can make this charge 0, is placed before this. Means the factor or multiplication factor that we have to take is kept at suffix. Means 2 atoms of chlorine we have to take. So molecular formula, 2 atoms of chlorine, Cl2. It is clear. Now magnesium, how much we shall take? Magnesium is only 1, means we have not multiplied because 1 itself contains 2 unit positive charge. So magnesium have to be written as it is. Okay, students. So write this. Here we have determined first the chlorine should be written as Cl2, and magnesium. Student, there is a convention that positive ion should be written first, followed by the negative. So MgCl2 is written, not as Cl2Mg. It becomes wrong because UPSC and in chemistry it is accepted that first positive ion called cation should be written, then the negative ion, means the number of negative ion required to make it neutral, then anion should be written. Okay, it was this one. This way I had explained here many more things, that these atoms combines, or atoms have the tendency to get the noble gas configuration, and this noble gas configuration decides which magical number, means how much valency or how much positive or negative valency shown by that atoms. Okay, student, it is this one. Here we have observed, if it is before the noble gas, the valency should be taken negative. If it is after the noble gas, the valency should be taken as positive, but it should be up to 3-1 only. Okay, not for the fourth. It cannot be positive and negative. It is always neutral one. Okay, student. So these things we have to keep in mind. Now, here we have written that certain atoms which are before this noble gas, they have tendency to gain electron to form negative ion. This similarly, we also have to write the fourth point, that atoms or elements after the noble gas, so element or atoms, okay, after means it is up to 3 only, can, the purpose is why they become positive, they have the tendency to lose. How they can lose, this we will learn in our next chapter. Can lose electrons and form positive ions, called, these positive ions are called cation. Okay, student, I had already explained. Example, if we consider this sodium, then sodium, what ion and what valency it will show? So a student, we are knowing that neon, which is our 10, in serial number 10 it is neon, and after neon it is 11 sodium. It have 0 valency, so it is 1 after that, so it have +1 valency. Okay, if you are given with the aluminium, so first allocate the serial number after neon. I mean, at what serial number? +1, +2, +3 is there. It is 13. That table is very important. So +3 it will show. Okay, it is like this. So this was other important point that we need to keep in mind. So how this positive and negative? Students, write down the fifth point. There are certain group of atoms showing net positive or negative charge. Okay, so these are also called as ions, but a special name to them are polyatomic ion. This we will write the table. Example, a student, if you take nitrogen and hydrogen, in place of 3, if you are taking the 4, then it is found that it is always having 1 unit net positive charge. And this ion, this is not the molecule, it is ion. It is positive, so it is called as cation. So this cation may be of the 1 atom only, like our sodium here we have taken, or maybe of the more than 1 atom. Here also, how much charge is carried by this group of atom? +1 unit. So this implies here, for this ion or polyatomic ion, the valency is also here plus 1. Okay, so in place of sodium only, it may be the NH4 plus, and this NH4 plus, the name given is ammonium. Ammonia, NH3 is ammonia but carry positive ion, and the name is derived from that, ammonium. So change this ammonia to ammonium. So it is our ammonium ion. It is like this one. So what are the various ions that we have to understand for that? Students, here we have learned this thing. The 6th point that we need to keep in mind is that these positive and negative ions are attracted or combined together to get neutralized. This way the molecule is formed. So right, positive ions also called as what? The other name to this is cation. And
Cation.
negative ions, the
Anion.
good, so anions, maybe one anion or more than one, combines together to neutralize their charge. Neutralize their charge, and hence form what is the group of atoms will get attracted and they will remain together. This way the molecule is formed and hence forms molecule. So this is what the molecule formation. Example, a student, if we are considering the sodium we have, and near to this sodium there is chlorine. What will be the formula for the compound that contains sodium and chlorine? So first you have to understand this sodium is showing what? Plus valency. So it exists as Na plus. So rather than sodium you need to think for Na plus. For chlorine you need to think for Cl minus. Now these plus and minus have to be get attracted, or these have to be attached. So what you will do? Na you will write first positive ion you have to write, then chlorine you will write next. Here you are observing that the sodium have plus 1 unit charge, the chlorine also have plus 1 unit charge. So you may understand like this, Na plus 1 or 1 plus, Cl is also our 1 minus. So whatever this you have to put it here, and whatever this one you have to put it here. So it is like Na1 Cl1. This will be the molecule, but 1 is not written, so these two 1 can be dropped or can be left. So ultimately the formula become NaCl. This is the answer, or this is the formula. A student, similarly you can also think for the second. Let us consider Na have to combine with oxygen. What will be the formula? If Na is combining with oxygen, then what will be the formula? A student, do with me. Na, observe carefully. Na will have to exist as what? Na plus I need to think, or Na1 plus rather. Oxygen, how I shall think? 2 minus. So for writing this, first I have to write the positive ion, then negative ion. So write Na1 plus or Na plus only, and oxygen 2 minus only. If you have doubt, you may write Na plus as Na1 plus. Now this one you have to write at the end of other atom, and this 2 which is over the other ion or other atom you have to write for the first one here. Means cross multiplication is simply you have to do. Many times it is also written like this. Write Na plus oxygen 2 minus. So you write the number, means whatever the number here, you just write 1, means how much positive ion, it is 1. How much negative ion, it is 2. Okay. So you have to just put this one here and this 2 here. So whether you write this way or this way, you will get the same thing. It is just way of writing. So the formula become what? Na have to be 2 times Na2O. This will be the formula for the molecule formed by combination of sodium and oxygen. Are you getting? So it is called as sodium oxide. Okay, students. So here we have learned different atoms are forming different kind of ions and they are getting attracted. A student, what are different kind of atoms or ions which is formed and the table? So this table is very important in writing the molecular formula and determining the mass. So for writing the molecular formula and determining the mass, we need to keep this table in our mind. So right, for writing molecular formula and next getting their mass called molecular mass, we need to mug up this table. A student, for writing the molecular formula, here we have observed that molecular formula is formed by combination of atoms, and atoms first form their ions, then those ions are getting attracted. So how these atoms are forming their ions, that we have to keep in mind. For this table means how much valency it is showing. It is very important. Say hydrogen may be +1, -1, when positive, when negative, we will learn later. Helium is a noble gas, so no valency. Okay. Coming to this lithium, +1 valency. Beryllium, +2 valency. A student, so for all these elements, what we have to keep in mind is their this thing, at least their valency or the charge, so that in ion form, how this lithium or how this beryllium will be represented. So while lithium will be represented as Li plus, while it will form the ion, beryllium will be represented as Ba2 plus. Say boron, B3 plus. Coming to nitrogen,
B3 plus.
yes, nitrogen, which ion and how it will be represented?
N3 minus.
Good, N3 minus. Get it? It is also written at the end. Last day I had also explained, so it is like this one. So remembering these ions are very important. Exclusively their valency, means how much charge it is showing while it will combine. Another important thing, for getting their molecular mass, we need another data in this table or another property of these elements. Keep in mind, that is their atomic number. A student, here we have written the atomic number at the last. So for each atom, certain weight or certain mass is there, and different elements are showing different kind of masses. Hydrogen is the lightest one and its mass is 1 U. If we are considering the one atom of hydrogen, its mass will be 1 U. But if we are taking the Avogadro number of hydrogen atom, it will be 1 G, means 1 gram. Similarly, for helium, the mass is 4 U for one atom of helium. For Avogadro number, means 6.022 into 10 to the power 23 atoms, then its mass will get converted into gram. and it is written as how much? 4 gram. So this implies it becomes 4 gram for helium. Similarly, so you just remember this number in your mind. Forget this U and G. U simply indicate it will be for one atom, and if G is there, you have to keep in mind it will be 6.022 into 10 to the power 23 atoms. Okay. For beryllium, the ion is +2, means +2 valency, and the mass is 9. Okay, it is this one. Boron +3 valency, so boron will be represented by B +3 and mass is 11. Okay, student. Coming to carbon, very important. Carbon have the mass 12 U or 12 G, and valency is represented by C4. A student, avoid writing this +4 or -4. Avoid this way of writing, because this carbon is not showing positive or negative valency. They are just showing by sharing. This we will learn later. Coming to the nitrogen, what will be the mass and what will be the formula of its ion? A student, mass is 14 and formula is N3-. For oxygen, it is our 16 AMU and formula is of their ion is O2-. Fluorine, it is F1- and mass is 19. Neon 20, and it do not show any kind of valency, so it will always as neon only. Okay, because these are noble gas, which do not have tendency to react. Sodium always as Na+. So that's why I had taken this in illustrating one of the example. And mass is 23. So this mass number is important for writing their molecular mass, and these ions are important for writing their formula of the compound. Similarly, for aluminium, mass is 27 and ion is Al3+. Silicon 4, leave the charge, mass is 28. Phosphorus, mass is 31 and it is P3-. Sulfur S2-. Okay, student, it is this one. Coming to the other important, chlorine, mass is fractional or decimal 35.5 and the ion form is Cl-. The coming to next one, argon. Argon mass is 40, but since it is noble gas, so it will not form any ion. Okay, so it will exist as Ar only. Coming to potassium, just one after this noble gas, so 1 plus is +1, K +1, mass is 39. Calcium 40 and ion is our Ca2+. Up to this much 20 you have to keep in mind. These are very much frequent. The other important are the beryllium. This will come later. So beryllium, it have +2 valency. Mass is not important. It is the bigger or higher one. So the ion is only you have to keep in mind. Another one is bromine. Bromine is the brother of chlorine and fluorine. So it is Br-. Copper, Cu2+. Then iron is the important one. Iron is mostly showing +2, sometimes also showing +3. Okay. Gold and these things are not required. Another one is our zinc. For zinc, +2, so it will form Zn2+. Okay, student, up to this much it is enough. So these are the data that we have to keep in mind. So whatever the things we have learned, based on this we can form the molecule of any elements. Okay, we have also learned that there are certain other group of atoms which are existing in ions form. Okay, and they completely forming the molecule, means they will always acting as single entity. So write those things. So student, for molecule formation we need, right, for write this molecule formation, what we need to understand the atoms, rather atoms, better to understand these atoms in the form of their ion if we want to write the molecule. We are also knowing there are certain group of atoms. If these group of atoms having charge, so this we need to consider, or if the atom itself is there, then how much charge it can carry, that we need to keep in mind. So these atoms carrying charge or group of atoms carrying certain charge is called ions, means these two. So atoms having charge, let me write like this, atoms having charge. So these two are collectively forming a species or entities which is used in formation of molecule. It is called as ions. Okay, so ions means nothing but it is charged particle. Now this charged particle may be of the two type, or charges are broadly of the two type. One is called positive charge, another is called as our negative charge. So whether we call for ions or the charge, it is of two type. One is called
Cation.
yes, one is called as positive ion. Positive ions have a special name called cation. Okay, or the other, it could be the negative ions.
Anion.
Good, so it is called as anion. Okay student, now this positive ion can be over the single atom or maybe over the group of atom. So right, cation of element means single atom. We have to keep in mind this is the category. Or maybe the cation or positive ion of what is called group of element, group of atoms, means the group of atoms together carry that charge, not the single atom. So that entire group we have to keep in mind. So such group of atom, they are called as polyatomic. So it is called as, write in bracket, monoatomic cation. Atomic cation. More than one atoms or elements are there, they are called as poly, means more than one. Atomic, the category is positive charge, so called as cation. What are the example? Example we need to keep in mind, student. If we consider the hydrogen, how the hydrogen exists? As H plus. Okay.
H plus.
If we consider the Na, How this Na exists? As Na plus. So it is called as simply sodium. It is hydronium or hydrogen only. Hydrogen. This table we are writing, it is very important, and the name full form we are writing, it is also important. We have also taken the other one, Li. How Li? Lithium exists as Li plus. It is called as lithium. Many more we have taken. Whatever the plus 1, plus 2 that we have taken, we can take this. How the magnesium exists? Mg2 plus. It is called as magnesium.
Magnesium.
Good. So student, let us write all these things. Here we are observing these are carrying 1 unit positive charge. 1 unit positive charge. 1 unit charge. Let me write one more for the 1 unit charge. I'm just collecting those things. Say potassium. How this potassium was existing? K plus. It is called as potassium. So all of these have how much charge? 1 unit
1.
charge. So such atom which carry 1 unit charge, they are called as
Monoatomic.
monocation. No, all are monoatomic. That other we will write. The other that we can write is in the same category. We can take the other one also. Say copper. So it is found that copper also showing plus 1 as well as the plus 2. So it is our copper. But a student, copper have two category, either as plus 1 or plus 2. So it is showing 1. So the number 1 is written in Roman in the bracket after that. It may be your silver also. Az if you are taking. So Az will also act as plus 1. It is our silver. These things we need to keep. Other, if we consider, come to the other element, that this thing I have selected from that table only. Student, do not forget. From this table, I am selecting the plus 1 charged particle. Observe this, student. Mark from this table. I have taken this plus 1, means lithium plus 1. See, coming at the end, sodium plus 1. Then potassium. Yes, potassium plus 1. This I have taken. Coming to the copper. Copper is showing both kind. So we can take this as plus 1 also or plus 2 also. So it can be Cu plus also or Cu2 plus also. Okay. Like iron, copper is also showing 2. So this is called as cuprous and it is called as cupric. Okay. Asandic. More detail you will learn in higher standard. So student, here I have taken for this copper. Another for silver we have not written, but we shall write because it is in your book. So another one is the denotation of silver, argentium, that we have written Az. So it shows plus 1 and it exists as Az plus. So these are the cation that I have selected which carry 1 unit positive charge. So I am just tabulating whatever the information we have discussed, so that you can just watch this table, you can understand easily, or you can easily form the molecule. For that, it is also possible to have atoms with 2 unit positive charge. So a student, take few of them. What they were? They were the beryllium, Be.
Mg, magnesium.
Good. The Be 2 plus. What was that? Beryllium.
Beryllium.
Another magnesium that we had written, Mg also exists with the 2-unit positive charge. So this is our magnesium. So this charge over the atoms have to be kept in mind. This is important for writing the molecular formula. So magnesium. The other with 2-unit positive charge, there we have written in that table. What they are? Could you recall some of them? So copper. A student, copper can also show 2-unit positive charge. So copper 2 is denoted as Cu2 plus. The other,
Sir, iron.
yes, the iron. So iron with 2-unit positive charge as Fe2 plus. Okay, whether you write the symbol first then name or the name first and symbol next mean the same thing. The other important was our zinc. Zinc Zn2 plus. So these are some of the important. Other was our calcium. What was the formula? Ca2 plus. So all of these have +2 charge. Okay, student? So similarly, it is also possible to have 3 rather than this 2. It is also possible to have 3-unit positive charged. So how they are? Could you recall for the 3? Yes, student? Yeah, tell me one example which have the 3-unit positive charge.
Aluminium.
Very good. So one of them is aluminium. There are many more, but at least aluminium we need to keep in mind. Sorry, let me create some space for writing it. So here positive ion or cation that we were writing, it is this one. Sorry. So let me rewrite it. A student, so it was cation. So it was our, or it is our positive ion, also called as cation. This group, so it is this group, this I have written. So cations may be of the 2 type, maybe cation of atoms or cation of group of atoms. Let me copy this part also and shift it above. Yes, student, recall for the 3-unit positive charged ions, what they were? One is aluminium.
Boron.
Very good. So right, it may be possible for, say, aluminium. How it is denoted? Al3
Al3 plus.
Another I had also written there, iron. Could you recall?
Fe3 plus.
Iron 3 with the valency 3. Good. So Fe3 plus. Other Boron. Boron also exists as B3 plus. These are the few that you need to keep in mind. So this, all of these are +3 charge. Okay, it was. Similarly, we can write for the group of atoms which is showing +1 unit charge, +2 unit charge, +3 unit charge. A student, we had written one example for this one, like our ammonium. So keep in mind, this is very important. Ammonium. Ammonium always represent 1 nitrogen with 4 hydrogen, and this unit carries 1 unit positive charge. Means you have to understand like this. This ammonia is what? NH4. It is always together, and this group is carrying positive charge. So while forming the molecule, this NH4 have to be kept together. Example, if ammonia is combining with the chlorine, then means this ammonium NH4 have to be kept together with positive charge, and chlorine we have learned Cl minus. So this one have to be written here, and this one have to be written here. So it become NH4Cl. If we are considering this ammonia NH4 plus is going to combine with the oxygen which is having 2 unit negative charge, then a student, this 2, it means for NH4 the valency is 1 or +1, but oxygen it is the 2. So keep in mind, these 2 have to be multiplied with entire ammonia NH4. So NH4 have to be kept in a bracket, then this 2 we need to put, and oxygen, for that the suffix 1. So the formula become like this. NH4, since this unit have to exist 2 times to neutralize the charge, so NH4, after that this 2. So these 2 also indicate all the atoms in this ion is occurring 2 times. Then oxygen will be only 1. So it is ammonium oxide. Are we getting? So this is the difference between considering the polyatomic cation or cation of group of atoms. Okay, students? So it is that difference. So this we have to keep in mind. Now let us go for the other. So only one is enough for you. More than this is other are not required. Consider, now come to the other one. In polyatomic only one is enough for you, because in your book only one is given, though there are other also. So for polyatomic with 1 unit positive charge. Now let us come for the polyatomic with negative charge, or the negative charge ions. For this, what are the various groups and categories that we have to keep in mind? Like positive ion, these negative ions can also be distributed or can also be divided into 2 groups. One is called the negative ion of element, or cation of, anion of element. So this can be divided into 2. So write this. So divide it. So this can be divided into 2 groups. One is called what? Anion of which one? Elements, students.
Elements.
Very good. And so this will also called as what? Like monoatomic cation. It is our
Monoanion.
okay, good. So monoatomic anion. It is M, not N. Okay, no, mono atomic anion. So for monoatomic anion, again the charge could be 1 unit, 2 unit, or 3 unit. So a student, it is monoatomic anion. Let us take the
Anion.
example of this. Yes. Example. So take monoatomic anion. We have learned how the fluorine is existing. F minus.
F
How the
minus.
fluorine? Yes. This is called as fluorine is the name of the element. But while it carries negative ion, the word IDE is added with that element. So it is written as fluorine is the normal element. Now this become INE. You have to remove this NE and you have to add IDE. It become fluoride. Okay. Chlorine Cl minus.
Bromine.
Chlorine, what become the name of this Cl minus? How the chlorine will exist? Cl minus. And what will be the name for that? It will be our
Chloride.
good. Chlorine is the normal name. Here you drop the any these two, and in place of these two you have to add IDE. I is already there, so it is chloride. We have also learned Br minus. It is
Bromine.
bromide. A student, keep in mind these things. These are very important. Only this is the tool that will make you understand what is the molecule, and you are able to write the molecular formula. Without this, you cannot write the molecular formula. So then iodine, I minus, it is called as iodide. We have learned chlorine, bromine, iodine, fluorine. These are brother of each other. Another, we have also learned hydrogen can also show negative. Though earlier we had marked the hydrogen as positive. So hydrogen can show both positive as well as the negative. So this hydrogen is now written as hydride. So right, it is our hydride, IDE. Okay, student. So hydrogen is a peculiar element that we will learn in our next standard. So hydrogen with negative as hydride, but hydrogen with positive as simple hydrogen. Okay, student. So all of these are carrying how much charge? So -1 charge. Getting? So it is also called as monoanion.
Monoanion.
A student, considering the valency, the name will be given that I will write at the end. It is also possible to carry 2 unit negative charge. Like we had written, oxygen is written as O minus. Is it okay? How oxygen? Which kind of ion formed by oxygen?
O2 minus.
Very good. A student, do not sleep. Other students are not speaking. So oxygen always exists as O2 minus, or oxygen form O2 minus for their reaction. It become called oxide.
Oxide.
From oxygen, it is forming the oxide. Okay, student? Then sulfur exists as S2 minus. It is called as sulfide. So ID is added at the end. Okay, student? It was like this one. Coming to the even the trivalent also. Students, we have learned how nitrogen exists. Nitrogen with 3 minus. It is called as nitride. So this way we have to keep in mind this O2 minus or S2 minus. These are carrying 2 unit negative charge. So we can write -2 charge. Now for nitrogen it is -3 charge. Okay, students. So these are regarding the ions of element or atom. But there is also possible to have an ion of group of atoms.
Group of atoms.
So this anion of group of atoms means more than one atoms are there. It is called as polyatomic anion. What are the group of atoms which are collectively showing negative charge? Like ammonia that we have learned. See this ammonia forming ammonium. Similarly, the group of atoms also carry some negative. So what they are? Like this we are going to write for the negative. If we consider it can again be, means if we consider like -1, -2, -3, that way we can also classify this polyatomic anion. If you have hydrogen, then carbon, then CO3, this group of atom carries 1 unit negative charge and it is called as bicarbonate. Bicarbonate. Sometimes this is also called as hydrogen carbonate. Hydrogen carbonate. So what is the name of which ion? That you also have to keep in mind. So whatever the formula of cation or anion we are writing and what is their name, everything you have to keep in mind. Next, if we consider the other, like oxygen attached with hydrogen, it is also showing 1 unit negative charge. It is called hydroxide. Hydroxide. Xide. Okay, student, it is hydroxide.
Sir, can we include HCl?
HCl is not carrying the entire charge. Only Cl is carrying negative charge and H is carrying positive charge. What you are asking is like this. HCl is formed by combining the Cl minus and H plus. They get neutralized. HCl is not a charged particle. Okay, it is a neutral molecule. So don't get confused. It is OH minus entire, means this group of atom is carrying a negative charge. While forming the molecule, we will see this. So do not get confused with any molecule. It is not any molecule, but certain group of atoms which are carrying the negative charge. So I am writing that one only. Take the other one. If you are taking nitrogen and oxygen 3 means NO3, then it also carries 1 unit negative charge. It is called as nitrate. Student, the differences you must keep in mind. It is nitrate, ATE, nitrogen with oxygen. But it was nitride. Recall this. Come to this one. It was nitride where only one nitrogen was there. Are we getting this? So this thing we need to keep in mind. Nitrate and nitride. Means if we have to write the nitrate, we have to take NO3 minus as the unit. But nitride, then N3 minus. Write down the other one. We are getting too late. Okay, let me finish it quickly. The other one, only these three are important for you in mono or for the group of atom carrying 1 unit negative charge. So these are also carrying 1 unit negative charge. Is it okay? Now coming for the 2 unit negative charge, if you have CO3, then it carries 2 unit negative charge. It is called as carbonate. This thing you have to mug up and you have to write this table as homework. If you have S sulfur with oxygen as 3 atom, then it also carries 2 unit negative charge. It is called as sulfite.
Sulfite.
If this sulfur combines with even 4 oxygen, it still carries 2 unit negative charge. It is called as sulfate, ATE. Again, here differences you need to keep in mind. It is ITE, it is ATE. Okay, here it was 3, here it is 4. So this thing you have to keep in mind. So all of this carries 2 unit negative charge. Now coming to the 3 unit in polyatomic. A student, in addition to this, there are other also, but at your level. So let me write few more, which may not be in your book, but it is useful. So if you are taking Cr2O7, it is called as, it is also carrying 2 unit negative charge and it is called as chromate. Chromate. We will write the potassium dichromate. It is basically the dichromate. If only one is taken, then it is called as monochromate. So no need to mug up right now. Whatever in your book, at least that much you keep in mind. Coming to the -3, if the phosphorus is attached with 4 oxygen, it carry 3 unit negative charge, means -3. It is called as phosphate. Phosphate, ATE. Again, there we have somewhere written regarding for the phosphorus as phosphide. What was that? We had not written. The phosphorus is only there, then it carries -3. It is called as phosphide. Like nitride, phosphide is there. But if PO4, then it carries 3 unit negative charge. It is called as phosphate. So these are the ions that you must keep in mind. Do not forget this. It is very important. Students, here we are observing that we have 4 categories of ions. So all these 4 categories are very important. Here one more term we need to keep in mind. Only the term. What is that term? That I will write. A student, if the charge is +1 or combining capacity is +1 or -1, it is called as monovalent. Okay, so all these group, a student come here, all this group here we have observed, all these are carrying +1 unit charge, so it is our monovalent. Monovalent. So many a time monovalent term is used. Also, -1 is called as monovalent. Then how to differentiate these two ions? Since it is positive, so first group with +1 unit charge is called monovalent, cation, student. And -1 unit charge particle are also called as monovalent anion. Okay.
Anion.
Now coming to 2 unit charge, even this is also monovalent cation. Okay, no, this whatever we have taken, it is also monovalent. It is not depending on the number of atoms, but rather it depends on the charge, whether it is charge is 1 or 2. So since the charge is 1 here also, therefore it is also falling in monovalent cation. Means ammonium is also monovalent cation, though it is polyatomic cation. Okay. Now, a student coming to the +2 charge or -2 charge. So +2 or -2, this number 2 as valency is called as divalent. So wherever
Divalent cation.
yes, it will also be your divalent. But +2 means it will be divalent cation. But -2 means the valency 2 means it is divalent, but
Anion.
good. So it is our divalent anion. Okay, student. The next one is our coming for the 3. So when valency is
Trivalent
3,
cation.
very good. It is called as tri. So tri, but valency is 3. So trivalent, and it is positive. So cation. What will be the name for this one? All these ions will fall in the category of trivalent anion. Okay. So trivalent anion can again be for the atoms only or for the group of atoms. So these are the things that we need to keep in mind. A student, all these formula with their valency are very important, that we need to keep in mind. Okay, these are very important. So you must write this thing in your notebook once again. Similarly for the aluminium, iron, boron, so plus sign is equally important. And it was the ammonium only. This symbol was this one. Coming to the negative, fluorine, chlorine, bromine, iodine. This hydrogen carries extra significance, so mark it in the box for the hydrogen in addition to highlighting it. Okay. Then highlight the oxide, sulfide for -2 unit charge, nitride, phosphide for -3 unit charge. So it was for the atoms. Coming to the polyatomic with -1 unit charge, it could be bicarbonate, hydroxide, nitrate, carbonate, sulfate, this sulfate, this oxalate and dichromate. These things are not important right now, but in class 10th we will use it. Okay, so at least this much thing we need to keep in mind in this table. Okay, so this table is very important in forming the molecule. Now let me show you how the molecule is formed. Now a student, you have to write the, so write formula for these compounds. A student, I am taking few example. Say magnesium hydroxide, if the formula is written like this. The second one is our calcium carbonate. The third one is potassium chloride. Fifth one, or right on the fourth one, magnesium sulfate. We will see how we can write the formula for all of this. Third one is it is calcium. Sodium chloride. Write down the sixth one. Aluminium oxide. I will write only this one. Other for writing the formula and just reverse the name, you will practice from your book. That I will give you as homework. A student, let me explain the magnesium and hydroxide. A student, these two, for writing the formula, this magnesium hydroxide consists of the two parts. One is magnesium and another one is hydroxide. So you need to search what is the formula for magnesium and hydroxide. What is in this table? A student, observe this. Where is our magnesium? Can you search it anywhere? +2. A student?
+2.
It is our magnesium. Are you getting this? I am highlighting. Are you getting? This is our magnesium. So up from positive side, I need to search from the positive. And hydroxide come to the negative side with polyatomic anion. It is. Are we getting? So along with the charge, we need to write these two. Is it okay, student? Means I need to take this one and hydroxide this one. These two things we need to take. Getting? So take these two and write it on the other side where we want to write the formula. So students, here we have to take the magnesium as the first. So write for magnesium, how this magnesium is existing in ion form or charge form? Mg2+. Okay, student? Or Mg+2 or Mg2+, you write mean the same thing. Now, for this magnesium, I have written this. Similarly, for hydroxide, you need to write the ion here. OH-. A student, we need to keep in mind this OH- together we have to write. Means OH is acting as the single entity. Okay, so if you have doubt, you always put it into a bracket. Okay, if you have doubt. If not doubt, then you can leave it. A student, now write the valency below this. What is the valency for magnesium? Mg2+, means it is +2. Write the 2+ directly below it. It is our 1-. Okay. Now, a student, leave this positive and negative sign. Okay. Now, whatever the number is there, that number you have to write in the crossed manner. This one you need to write for this magnesium, and the 2 you need to write for this OH whole, not for H only. Okay, because the OH itself is acting as the complete ion. So write it. So it becomes like this. Below magnesium, I need to write 1, and then I have to leave their charges like +2 and -2 or -1, we need to leave it. But OH, this is the complete set which is occurring how many times? 2 times, students. So we need to put the 2 here. Means after this OH we need to put the 2. So what is the formula? You can leave this 1 whatever we are writing here. So the formula is simply written as MgOH whole twice. This is the required formula. Okay? Are we getting? Now let us come to this calcium carbonate. A student, write for the calcium. What was for formula for calcium? It was Ca2 plus. Carbonate, a student, you have to mug up or you have to keep in mind 2 minus. You have to write there this radical at their end. So you may write the 2 below it and 2 below it, then these 2 here and these 2 collectively. After this bracket we have to put it here. You may do like this, or you may leave it. You may directly write the cross multiplication like this. You may just leave it. You may directly write the 2 which is for this negative here and this 2 here. Okay, means you can write this calcium as 2 and this CO3 also as 2. Are we getting? It is appearing like this. But wherever some common factor between these 2 number, means the 2 suffix we are writing, from that common factor we can divide it. So what is common to this first 2 and this next 2? 2 itself is the common. So these 2 and these 2 can be cancelled, and in place of these 2 I can write only 1 and 1. So whatever the common factor, you can leave it. So it is like our Ca 1 time and CO3 also 1 time. Now Ca1 can be simply written as Ca, no need to write. Now CO3 is also only once. Means this 1 can be left and this bracket can also be left. Because CO3 itself is acting as 1 unit and it is only 1 time. So the correct formula is CaCO3. Are we getting? So this way you have to understand how to write the formula. Let me do one more. Potassium chloride. A student, what is for potassium symbol? K plus.
K.
K 1 plus. And chloride, for chloride what we have?
Cl minus.
Very good. TCl minus. Means it is 1 here and this 1 for the potassium will come here. I may write like this. Potassium also 1. Chlorine also 1. So 1 can be left. So it is simply KCl. Are we getting? This is the answer. Similarly, magnesium sulfate. You, a student, please tell me now for magnesium sulfate. So magnesium I need to write Mg2 plus.
Mg2 plus.
Sulfate. Yes, other students are not getting, excluding Valino, other are not, neither is speaking. Or are you getting? If you are not getting, then please ask me. A student, come for this sulfate. What is the formula for sulfate? If you have doubt, you may go back and search in this. Come to this sulfate. Where is our sulfate? A student, observe on the right hand side. It is our sulfate. Are you getting this? I am highlighting the sulfate. Okay? Means SO4 minus. 2 minus I shall take for writing the formula. So write that. Sulfate. Students, we have to take the SO4 2 minus. A student, keep in mind this SO4 is exactly like our CO3. Means collectively we have to put in the bracket. Means these 2 shall come here and these 2 shall come here. Means after SO4. So for writing this, it should be like this: Mg2 SO4 whole twice. But here these 2 and these 2 are common. Means both
MgSO.
have the 2 as common. So these 2 can be left, means Mg as 1 and SO4 also as 1. So when SO4 is only one time, I can leave this bracket also. So the final formula is like our MgSO4 even without bracket. So this is our final answer. Yes, I hope a student are getting this. So it is our MgSO4. Any student have any doubt, then they may ask.
Sir,
Yes.
sir, in first question, can we write without bracket? OH2.
No, a student, I am cancelling or removing the bracket only if it is occurring only one time. Let me take one more example before going to the other. While you have asked the question like this, let me take the 7th one itself. Say ammonium sulfate. Let me first explain this ammonium sulfate. A student, ammonium sulfate means I need one ammonium, another sulfate. What is this ammonium? Ammonium is NH4.
NH3.
Ammonia is NH3, but ammonium is NH4 with 1 unit positive charge. Sulfate means SO4, 2 unit negative charge. So I need to put these 2 here. Means after this NH4, whole NH4, I shall put this 2. And this 1 is here, I shall put after this whole, I shall put 1. So the intermediate one will be like this. It become like our NH4 whole have to be kept twice. And SO4 whole have to be kept only once. Okay, student. Now wherever 1 is there, only at those places you can leave this bracket because it is 1. Now in this 2 and in this 1, nothing is common. So we cannot cancel these 2 and 1, means it will remain as 2 and 1. But for the 1 at the end of SO4, this bracket can be left. But for this NH4, this bracket have to be maintained. So it is like NH4 bracket, you need to maintain it, NH4 whole twice, than SO4. Only this much is the answer. Okay, student? So this way, you need to keep in mind, if the suffix is more than 1, you cannot leave the bracket. Okay, student?
Okay, sir.
Let me take one more example. Let me take one more. Say, aluminium carbonate. If anyone is asking to you for the aluminium carbonate, what will be the structure? A student, write for the aluminium, it is Al3 plus. Carbonate, what is the structure or ion?
CO3 2 minus.
Very good. Now, a student, we need to bring this 2 for this aluminium and this 3 for this. But for bringing the 3, I always need to keep CO3 as 1 unit. So we need to put it into a bracket. So write this Al, but Al is representing only one element. So this bracket can be left and I can write this 2 as it is without putting a bracket. So bracket is required only if more than so Al2 CO3, but this CO3 is occurring how many times? Whole thrice. So this is the answer. Are you getting a student now? I hope so. You might be getting everything. And I am very much clear. So that's why I had explained everything regarding the ions that you must keep in mind. So whatever the formula we were writing, all are found by combining these ions or these atoms. How this CO2 and H2O, that I will also explain. Come to this aluminium oxide now. For this aluminium oxide, aluminium is our 3 plus. Okay,
A will
student?
3 plus.
Oxygen 2 minus. So what I shall do? These two I shall bring below the aluminium and 3 after this oxygen. Now this aluminium and oxygen are only atoms. They are not the group of ions. So no need to take the bracket. Al2 and oxygen, the 3, that we have to keep in mind. It is this one. Is it okay? So this way we need to keep in mind all the things. So this was all about our, how is this? Now if we consider the water or hydrochloric acid or hydrogen chloride, let me take one more. Say the 9th one as hydrogen chloride. Students, how to write for the hydrogen chloride? Hydrogen I shall write, chlorine I shall write. Now, student, for hydrogen, I can have H plus or H minus. These are the two possibilities. But here hydrogen is given, not hydride is given. Okay? So I shall take H plus only. So write H plus. Chloride, ID is negative, Cl minus. So this one will come below the hydrogen and one will come after this chlorine. It means it is like H1 Cl1 without putting the bracket, because these are the ions of atom. One even can also be left. So it is our HCl. So HCl is a molecule. HCl is not an ion. It is one thing. Now, student, come to the another one, say water. 10th one is our water. Water is nothing but it is hydrogen oxide. Okay, it is our hydrogen oxide. It is this one only. So what will be the formula for this? Hydrogen I shall take with the plus
Plus
1
1.
and oxygen with minus 2. So what it will form?
Minus 1.
2 will come below hydrogen and 1 will come after this. So hydrogen twice, oxygen once. So it become H2O. Are we getting? It is like this one. If we consider the ammonia, ammonia is hydrogen nitride. So write that one also. If we are writing ammonia, ammonia is the common name. It is basically hydrogen nitride, like this. Though there is covalent bond in these two, more detail we will learn. But for your understanding, how is this? We can write up to this. So it is like this, but the exact structure and which kind of bonding is there, that we will learn next year. Hydrogen H, nitrogen is our 3 minus. So 3 will come here, 1 will come here. What it become? Hydrogen thrice, nitrogen
NH3.
once. So it is our NH3. So how the formula we were writing, everything can be written. Now coming to the carbon dioxide. What is the formula?
CO2.
Yes, but how this is coming? Carbon dioxide. A student, keep in mind, for carbon dioxide, for a moment you can leave their charge. So let us first understand this. It is our carbon and dioxide. So I need to keep in mind how is carbon and how is oxygen. Keep in mind, for a moment you just forget the negative and positive. What is the valency for oxygen? It is 2. For a moment you just leave the minus sign. For carbon, what is the valency? It is 4. Okay, so how it need to form? These two shall come here and this 4 shall come here. So it shall form C2O4. But for writing the formula, this common to be cancelled. So 2 ones are 2, but 2 twos are 4. So what we shall write? Carbon I shall take once and oxygen I shall take twice. So the formula is our CO2. Are we getting? So this technique you have to keep in mind. Okay, student? It is our carbon
Sir,
dioxide.
I am having doubt in hydrogen nitride.
Yes, tell me.
Sir, in hydrogen nitride, hydrogen has positive charge, so it will come first, no? Why NH3? It can become.
It shall come. You are correct. But I had told you, even for these two, say for the water, ammonia, these I had just explained you with the help of valency. But in fact, this is the correct one. The thing is that these are formed by sharing. It is covalent bond basically. Covalent bonding. What is this covalent bonding? There is no ion, rather there is sharing of electron. Sharing of electrons without ion. So here ion is not formed. Ions. But for your understanding, this thing can also be understood in term of ion. It also gives the same result. That's why I have taken like this. So this hydrogen nitride, whatever I have written, and this charge I have shown here, this is not strictly like this. In fact, how is the structure? One nitrogen is sharing their electron with 3 hydrogen. So this is the hydrogen. They are bonded like this. How is this structure? We will learn in class 10. But why these 3? That can be understood with the help of valency. Okay? So that's why
Okay, sir.
I have just written. So in this case, it is the sharing, not the entire transfer. After the next chapter, we are able to understand this a bit more. Right now, it may be difficult for you, but after next chapter, I will also explain this. So student, this was all about. So write down the homework. Your homework is write all ions. Means cation, anion, everything. Cation means positive charge ion, anion means negative charge ion. So write all ions in above table. In above table. Once more you have to write by recalling. Means you have to write the monovalent, divalent, trivalent, monovalent positive, monovalent negative, everything. It will be one thing. Then you have to do the homework of you have to write the formula, and from the formula just opposite we may write down the name of that compound also. So write down your homework for the textbook. From the textbook, such explanation are also given. So on our textbook page number 39, a lot of questions are there where for a given name you have to write the formula. See, we can see it. Yeah, see. Are you getting? This is the example, or this is the homework I am taking. Please do this. It will be asked in your examination. Tomorrow and in our next class, I will also explain this.
Okay, sir.
So, student, here we are observing that if the name is given, writing their formula that we have seen, like sodium. So Na plus you will write, oxygen 2 minus you will write, 2 you will brought here. I had also explained it become Na2O. Is it okay? Like this. Now, a student, for this, say, if in place of formula, if I am given with the formula itself and then we have to write their name, the concept remains the same. See, how is this? Understand this. It is our Al2 SO4 whole thrice. What this was? Here we were observing that it is our aluminium. So forget the valency. Means at this end you can leave this, you can leave this. What are the cation or anion present? You just focus over that. And this negative ion is called as sulfate. So aluminium sulfate is the required answer. Okay, student? So writing the name from the formula is rather more easier. Is it okay? So please do this.
Yes, sir.
Say, student, let me explain one more. What is this? KNO3. We are knowing that NO3 is acting as nitrate.
Nitrate.
And our potassium. So potassium nitrate is the required answer. Okay, student? So very easy. So the table that we have learned along with their mass number and valence is very important. That is the key of this entire chapter and entire chemistry. The other thing are also very easy. What do you mean by the term chemical formula? So whatever this formula we are writing, all these are called as the chemical formula. So right? The chemical formula. So chemical formula is nothing but it is what? The molecular formula. Molecular formula. Or it is also called as, say, potassium nitrate is the complete name. But what is the formula for this? Formula is nothing but representing the compound in with the help of their symbols in molecular form. So it represent, or you may write like this as the complete definition if you want to define. So it is representation of a chemical or compound, you may write, in their symbol form. Symbol form. Okay? Or writing the compound with the help of symbols of atoms and ions. Means it is a writing compound. So compound means its full name. Say potassium nitrate. So with help of symbols of their constituting ions or atoms. It is example. If we are writing the sodium chloride, so this is the compound whose full name it is the full name. But the same thing can be represented as Na than Cl. How this NaCl form? That I had also explained. So this is the chemical formula. This is the chemical formula. So chemical formula for whom? For sodium chloride. Sodium chloride. Therefore, each chemical or each compound have a specific formula. Okay? So representation. So a particular compound have particular formula. Okay, this was all about. Shall we stop here, student? Did you get your homework? Yes, students.
Yes, sir.
Yes, sir.
Yes, sir.
Homework are very
Yes, sir.
important, and today class was very important. It have gone too long. Though without explaining this much, we cannot finish it. So that's why it have gone a bit longer and more than our usual. But anyhow, everything we have finished in this single class. So, yes, student, you please listen these videos again and